I don't think there will be any more people joining the webinar, so I'll just go ahead and start. Welcome to release webinar for Midas Civil 2016 version 2.1. You can download this PDF from our website at any time after the webinar is completed. In today's webinar, I'll briefly go over the newly added and improved features from newly released version and benefits that our users can achieve from those features. So there are two major categories prepared today. One is for analysis and design, which focuses about updates in analysis options, boundary conditions, and available section types per design codes. A second portion of the webinar is pre and post processing, which discusses more about general modeling applications, section and material properties, section and material property definitions, and reviewing the analysis results. Previously published release note, which this webinar is based on, it contains more text description of each update. So if you would like to know more about each of the updates, please go ahead, visit our website, and then download it and take it as a reference. So now I'll start with analysis and design updates. So first of all, material nonlinear analysis is now available for beam elements in the form of stress resultant beam model. For example, this is a specific example. In case of U-frame steel bridge from United Kingdom, both geometry nonlinear and material nonlinear analysis need to be performed for bottom frame beam elements. In previous version, program will not perform analysis when material nonlinear property was applied to beam elements. However, it is now available for beam elements for selected section properties. Selected section properties are shown above: channel, I section, T section, box, pipe, rectangle, and round section. Those are all pre-composite steel sections, and there are some prerequisite or preliminary assumptions behind those, or underneath those section properties, such as von Mises material property from plastic material properties only, and linear elastic is known as perfectly plastic zero hardening stress strain curve will be considered. Plastic axial force and bending moment about minor axis will be only calculated, and couple effect between axial force and moment will not be considered. Secondly, material nonlinear for plate elements are enhanced, which means in previous analysis approach, in-plane deformation of layer of plate element was neglected, which resulted overestimated stiffness of the layer. We fixed this, so we updated analysis approach from three-dimensional condition base, which is showing on the left, to plane stress condition base, which is showing on the right, and it is correctly accounting in-plane deformation in layer of plate elements, and the results should be more realistic. The bottom figures represent the calculation matrix of each application. If you guys have any questions or any errors during the webinar, please raise your hand. I'll try my best to catch them along the webinar. Second update is improvement on moving load analysis. In general, analysis performance can be manually managed by its performance can be manually managed by adjusting the multiprocessor under analysis options. However, previously it did not affect the moving load analysis. Starting from this version, this version of Midas Civil, multi-threading analysis, which is increasing the number of multiprocessor, it will affect the moving load analysis results and performance. The example structure above, it has 408 beam elements, 46 truss elements with traffic lane defined. As you can see from the table, previously it took 820 seconds to run just to complete the moving load analysis, but after this update, it reduced by 1/3, which becomes 271 seconds. Also, warping DOF, which was the major update on Midas Civil 2016 version 1.1, is now accounted for moving load analysis. You can see from the bottom figures that the result component for MW is active, and you can draw the moment diagram for the on the structure for moving load analysis, and also the result table is available. Continuing with the moving load analysis improvement, Eurocode and United Kingdom code traffic line optimization is now available at user-defined lane width. For those of users who are not familiar with traffic lane optimization feature, it is an option that allows program to allocate the vehicle load not at the center, but as well as on each end of defined moving lane to consider more loading cases in determining the worst case loading scenario. You can check the effect of lane optimization feature by checking the moving load tracer, which will give shifted the location of the vehicle. Third is triple friction pendulum isolator. With development requests from various users dealing with heavy seismic load projects, triple friction pendulum isolator boundary condition is newly implemented to our software. It is proven that I'll use the short term TFPI are both structurally and economically efficient than the general bearings. I would like to share how triple friction pendulum isolator in program is behaving in respect to academic resources within next couple of slides. So this is the what's showing right now is the input table for triple friction pendulum isolator. As we go on, this is the first sliding regime where the initial sliding is occurring, and as you can see, the comparison between the upper graph and lower graph. Upper graph is directly retrieved from academic resource, and bottom one is the Excel graph using the force and displacement values retrieved from our software. So as you can see, it's showing not exact, but it's showing very close realistic behavior from that of academic resource. This is sliding regime sliding regime 2. I try to emphasize where that the displacement is occurring based on the theoretical knowledge. This is sliding regime 3. As you can see, our program is generating very similar result as what's proven in academic field. Sliding regime 4, and the last stage. After I go through the PDFs, I'll briefly go over the triple friction pendulum isolator within the program. This is the time history force displacement graph that you can get from our software. More detailed and example model file is provided on our website. So after I finish this webinar, once I upload them, you can click on the download link, and then you can go directly to the example files and then test it on your own. Fourth one is tendon location for composite section. So in previous version of Midas Civil, program automatically assumed that tendons are only located in part 1, which is the girder section of the composite section. However, for some design codes, this was not always true. So we made additional option to choose for the users to choose where the tendon profile will pass through. As you can see, pass through within the composite section, either part 1 or part 2. So the left window is the input window where you can select tendon profile and composite section, and which part of composite section that you want your tendon to go through. This is only additional input, so if you don't define anything, program will automatically consider part 1, which is the girder section, as where the tendons are passing through, because that's the most general case for the PSC composite sections. Okay. Improvement on Eurocode composite section, concrete. More concrete composite section types are available for Eurocode 1992-2 design check. Previously, only general type PSC composite section was available, which required our users to generate the composite section using the section property calculator. But now our Europe users can define the PSC or define the girder section first, and then generate PSC composite for the design check in using the database, using the section properties from database. Similar to concrete composite section, only steel composite general type was available for Eurocode 1994-2 design check. Now, user-defined box and tub composite sections are also available for Eurocode 1994-2 design check, which means for the steel composite sections, the composite sections are defined using the dimension parameters that users input, as it is shown on the left. So before, composite sections had to be defined using the section property calculator, but now users can shorten and do it more rapidly, just inputting the dimension parameters. And AASHTO code, AASHTO LRFD 2012 improvement with the PSC composite sections, PSC composite design check. So for AASHTO LRFD 12, PSC composite section design check is now available. Many of United States users have already been using the Steel Composite module and its design check and report generator feature. Well, previous feature and this feature will broaden our users' project capability and their modeling applications. Yeah, not only PSC composite bridge, but also steel composite bridge. Improvement with AASHTO code LRFR with a PSC composite section load rating, as well as design check available for concrete composite section in AASHTO LRFD. Load rating check for concrete composite section is now available for AASHTO LRFR. Available sections are the same as the design check: composite I, composite T, composite PSC, composite general, and tapered composite sections. Improvements on IRC code design, which is India code, IRC 112-2012. So PSC composite section are now available for design check per IRC 112-2012 design code, as well as other composite sections that were already available within the program. One additional thing for IRC code, this time 112-2011, the reinforced concrete structure design check is available. Well, I thought I went through the design check and load rating information too quickly, so I just made a brief table just summarizing what was added through this newly released version of Midas Civil. So for design check, Eurocode 1992 PSC composite design check is available. 1994 steel composite box and tub section is available. For AASHTO LRFD 2012, PSC composite design check is available. And for load rating, AASHTO LRFR 2011 PSC composite section is available. As it goes on, design check for PSC composite section general for India code is available, and reinforced concrete structure design check for India code is available. Now I would like to jump to second portion of the webinar, the release webinar, which is pre-post processing updates. So previously, nodal coordinate system or nodal coordinate table was already in the program, but it was always giving the coordinate system or the nodal coordinates in respect to the global coordinate system, even though you define user coordinate system. Now it is fixed, and user can the nodal coordinates will be adjusted if user defines user coordinate system. This will be very useful when user has flared section or skewed bridge, or from the start it doesn't start from 0 and it goes into the angle, or even for the inclined sections, inclined foundations, this feature will be very useful. After I go through all the PDF, all the slides, I'll go to the program and then show how it's being changed within the program. Also, the nodal coordinate system based on nodal coordinates based on user coordinate system. The table can be imported to dynamic report generator too. Second is improvement on plate local axis aligning for result check. Aligning plate local axis for result was already available. However, there was an error. There was internal error with the definition, which did not allow our users to modify the aligned axis once it is defined. So that is fixed. Now our users can either add, replace, or delete the aligned plate local axis. I'll also demonstrate this after the webinar, after the PDF. New section and material database for cold form steel. New section and material properties are added to the database for Uni Italian standard and SS Singaporean standard. Cold form channel, pipe, box, and upright sections are added. For ICHA, which is Chilean standard, angle, double angle, star batten angle, I-shape channel, double channel, and lipped channel section properties are added. Cold form material properties such as EN 10.32.6 and EN 10.14.9-2 and so on are added to the program. Okay, so warping DOF, which was added on the Midas Civil version 1.1. It was a major update, but it had some internal error, and I believe many of our users went through a hard time when the version 1.1 came out. The major cause of an error was when the longitudinal stiffener was added, which is supposed to be hollow section, or well, not section but hollow. The program was internally so basically in order to consider the warping DOF, program took new approach of calculating section property by generating the internal mesh within the section property. But there was an error, and as I explained, it was causing a lot of trouble. And the figures are the common reported errors that when it was published at the first. As you can see, the longitudinal stiffener is supposed to be hollow, but it's generating mesh within the stiffener. Same on the right, and also for the box, the top composite section or box composite sections, which is supposed to be hollow, it was generating the internal mesh. All that errors are resolved and fixed right now. So the previous version when it first came out, version 1.1 is on the left, and what we see from version 2.1 is on the right. So it's still doing the internal mesh. It's still calculating the section property using the internal mesh, but it's doing a good job now. So as you can see, it's creating a lot of mesh in order to calculate the section property more accurately and more realistically. And not only resolving the error messages or errors that we had, we even improved our section property calculation, which is before, some of the sections that were successfully calculating the section property, well, successfully generating the mesh, the mesh size and the distribution was not very uniform. So updating from version 1.1 to 2.1, we redistributed the mesh more evenly. So the shear area of the section property will be calculated more realistically and more accurately. As you can see from the upper figure, comparing to the left one, it's more even and it's more not focused on one part of the section property. The bottom one, it's displaying that the internal mesh is more refined and refined for better calculation. So the major problem in the previous application of the section property was the taper section, because the program had hard time calculating the taper section properties. That is also fixed, and as an example, from what you see from the slide on the left, just running analysis for that model took 2 hours, but now it's only taking minute and 16 seconds. On the right, that structure took hour and 20 minutes. Now it's taking only 46 seconds. Even if we updated or we changed the way of calculating the section property, some of the things that are still consistent. So there is no change in calculating the torsional constant of composite steel I or composite I sections. That specific equation I believe is being used on the field too. So we maintain that equation. And since the new approach for section property calculation was added, there are a couple things that our users need to be aware of. The first one is section properties can be different from what you got. Can be different between what you got from previous version and this version of the software, because as I explained, the new approach is taken, and it will give you better calculation for section properties. The second is the section properties calculated from previous versions will not be automatically updated. Even you just open up the model file in new version of the Midas Civil. In order to update the section properties, you need to go to section properties and then either open the section property and click OK, or you need to click show calculation results for section properties. That will automatically update the section property of defined section. 3 is I believe sometimes our users save the model file in form of MCT format, which is text output and input. If you saved your model file in MCT format, when you importing it or when you bring it in to Midas Civil, it will automatically update the section property because that values are being saved in form of dimension parameters, and then program will automatically calculate updated section property based on that. Fifth one is improvement on soil pressure. There are a couple things that I want to go through. First, for inclined foundation, the projection area, which is parallel to the ground level, is correctly calculated. Previously, there were some errors, and we caught that and fixed it. Second, in previous version, program did not perform analysis when multi-directional soil spring was assigned to one node. For example, connection nodes between wall and foundation. If you for the basement, if you put soil springs from both direction, program would not perform analysis on that specific node, but it's resolved, and program will automatically calculate the soil spring stiffness and save it separately for the directions per direction. Third is effective area of surface spring was automatically defined as 0 when springs were converted to point springs. So when you define the pressure spring, the boundary condition, you can select either there is an option to convert it to the point spring. When you did that in the previous version, the effective area became 0, but in the new Midas Civil, it will be automatically and correctly calculated. The modulus of subgrade values can be checked and modified in surface spring support table for compression only type springs. Von Mises and maximum shear stress, which is Tresca stress, contour in model view. So von Mises or Tresca stresses could be only checked for the beam elements. It was only able to be checked using detailed beam detail analysis for single element. But from the new version, there is an option in the analysis main control data. If you check it on, program will display the stress contour for the entire structure on the von Mises or Tresca stress. There are some limitations, and the stress contour is only provided for listed sections, which is showing on the right bottom, which is angle, channel and double channel, T-section box, pipe. It will calculate the stress contour based on the stress points that's being displayed on that table, and that table can be obtained by clicking guide from the result stress contour option window. The last thing is different unit settings for tables and graphs in dynamic report. In previous version, when you save the image or table for dynamic report, the unit system was consistent with with what's being used in the software. You did not have freedom to select your own unit system, but now user can manually define the unit system for each table or the figure that user want to insert to the dynamic report. Now I'll just shift to our software and demonstrate a couple things, because most of the major updates were more theoretically, or it was related to the design checks, and for that, in order to show that, I did not have all the time. So I was planned to go through the nodal coordinate system and the plate local axis update, and section properties and material properties added to the software, and the triple friction pendulum isolator feature. So this is an example file that I created for this specific webinar, and as you can see, the coordinate system or axis is right now is global axis. So if we go to the node table, it will show the nodal coordinates based on the global coordinate system. Even if you go on to user coordinate system, it will show the same. But when we go to UCS and go to, you can define whichever way you would like to define. I'll just use the UCS and rotate the coordinate system in z axis by 45 degrees. So you can see that the coordinate system is rotating now in the z axis, and go to nodal table again. You can see that global coordinate system, it did not change. But if you go to user coordinate system, now it's giving the coordinate system. You can also copy these coordinates into Excel file, and then make a modification, and if you make a new file, make a modification, and then create nodes based on the user coordinate system. Please give me now I would like to just cover through the section properties and material properties that were newly added to the program. So go to properties, and first let's check the material properties. So these three cold form steel material properties are added: EN 10326 and 10149-2 and -3. Now let's go to section properties. As I said, from UNI, which is Italian standard, cold form channel, upright, and other section properties are added. and also for the ICHA, which is Chilean standard. Now I'll jump to the plate local axis, which is used for the result review. Plate local axis aligning. So this is the example model file that is already included in your C drive under Midas folder. This is from tutorial 3. Prerequisitely, I defined a structure group for this round section. So if we check the element to local axis, you can see that the local x direction is towards the surface of the tube section. But if we go to results, plate local axis, and select local axis x, local x in direction of global y, you can see that all the plate local axes are now aligned to one direction. This feature is very useful when checking stress contour or force diagram on the plate elements that are not aligned, or hard to find the uniformity of within the elements. For example, like these elements, where the local axes are pointing away from each other, you can align them and then check the resultant stress or force. Now I'll jump to the triple friction pendulum example model. This is a very simple example model for the triple friction pendulum system. I'll just open up the input window really quick. If you are not aware of what each the stiffness parameters are referring to, it is sharing the same input definition as the friction pendulum system isolator from our online help manual. So please go on to our online help manual and then type them accordingly. Just sharing the initial input table for the triple friction pendulum isolator, that what was being shown in the PDF or slides. This is it. And as a result, give me a second. The performance is already run. It's been ran, and then this is, as I explained, this is the exact the force and displacement graph that you'll be able to retrieve from our software. That was just a simple model file. There is additional one more model file which is a little bit more complicated. I would like to share that result graph and then finish the webinar. So the triple friction pendulum isolators are located at the bottom, the foundation of the structure, and performance has already been run. And then let me just retrieve the force and displacement graph. Oh, I think I muted myself last couple of seconds. Let me just go back to the program. So this is the result, the force and displacement graph for a little bit more complicated structure. If I please let me go back to the simple structure and then just go through what's being covered just one more time. Go to results. Yes. Now I'll go back to my slides and then just wrap up the release webinar for Midas Civil 2016 version 2.1. Give me a second. So thank you all for joining the webinar, and I know there were a lot of updates and a lot of information at once that I tried to deliver to you. But after this webinar, I'll post up the PPT that I used and the release note that's being published by senior engineer, and try to deliver as much as information for you guys to have better understanding of what Midas Civil has been updated, and how you can apply that to your project applications. So if you have any questions, please submit emails to esupport@midasit.com, or please contact your branch office. They will have good information about to resolve your questions, to answer your questions. So please contact either us or your branch offices for your questions. Uh, this is the end of this is all that I prepared. And one more time, thank you again, and please have a good rest of your day. Thank you.